So here we are going to discuss about determine the Nyquist sampling rate and the Nyquist sampling interval for the following signal. So what is Nyquist sampling rate is? Nyquist sampling rate represent f of s. The Nyquist sampling interval represent t of s, and we know that t of s is equal to 1 divided by f of s. So the question is sinc of 100 pi t. So if I take the Fourier transform for this signal, so the signal will look like this is ranging from minus 100 pi to 100 pi. Okay, and this value is omega. Okay, so x of j omega, and the magnitude of this value is nothing but 1 divided by 100 pi. 100 pi. Okay, so here this represent omega, right? So that is nothing but 100 pi. What is omega? Omega is nothing but 2 pi of f. Okay, so that is equal to 100 pi. So from this I can find the value of pi fm, that is fm represent the maximum frequency. Okay, maximum frequency, and it is in terms of hertz. Okay, so once if I find the maximum frequency, I can find the Nyquist sampling rate. So the Nyquist sampling rate is nothing but the fs must be greater than or equal to 2 times the fm. So the fs is equal to 2 times maximum frequency, that is 50, that is equal to 100 hertz. Okay, so if I find the value of fs, I can find the value of ts, right? That is Nyquist sampling interval. That is nothing but the 1 divided by fs, that is equal to 1 divided by 100, that is equal to 10 power minus 2 seconds. Okay, so if the question if they ask suppose if sampling rate is 100, okay, 100 hertz, okay, because it is a sampling rate. Okay, so if it is 100 hertz, here also this is equal to the 100 hertz, right? So both are same. So if the both are same, there is no problem. So the signal can be recovered, because if the sampling rate gives 100 hertz, here also if you see the sampling rate, we can recover the signal. Suppose this is for the first case. So suppose if the sampling rate is 150 hertz, okay, for example. So the sampling rate is 150 hertz, and hours is nothing but so if the sampling rate is it is higher than greater than the Nyquist sampling rate. Okay. Okay. The signal can be recovered. Otherwise it does leads to allays. Okay. So the next problem is the x of t is equal to 2 plus cos 100 pi t for t is equal to 0.0125. So from this t, I can find the sampling rate. Okay. So the sampling rate is nothing but 1 divided by t. So rate represents the frequency. So 1 divided by t is 1 divided by 0.0125. 1 divided by 0.125 is nothing but 80 hertz. Okay. So whenever the sampling rate, right, the sampling rate is greater than the Nyquist sampling rate, the signal is recovered, right? Signal is recovered. Otherwise, it will leads to aliasing. So how to find the Nyquist sampling rate? So this one is omega, right? That is 100 pi, and omega value, you know that 2 pi fm 100 pi. So from this I can write the formula for the fm is 50. So you know that the sampling rate, Nyquist sampling rate, Nyquist sampling rate, fs must be greater than or equal to 2 times fm. So the minimum value is 100, right? 100 hertz. So when I compare this one, the 80 is less than there is sampling rate 80 is less than the 100 hertz. So this will lead to alias. So let us see what is alias. Okay. So in order to visualize this one, I need to convert this x of t uh, into Fourier transform. Okay. So if I convert this one into Fourier transform, x of j omega is equal to, so for one, for 2 I can write it as 2 pi, right? So if we take a Fourier transform, so it will be represented as 2 into 2 pi of del times omega plus this I can represent it as cos of, cos I can write it as pi, okay, del times omega plus 100 pi minus del of omega minus 100 pi. Sorry, this is plus. Okay. So what it means is, so it will look like, okay. So at zero value it is 4 pi, 4 pi. Okay. For omega, x of j omega. Okay. So at 0 value it is 4 pi, and at 100 pi it is pi. At 100 pi it is pi, and at minus 100 pi also it is pi. Since cos pi is an even signal, this is how it will look like. Okay, right? So if it is get repeated, which means from this I can write the sampling rate value is 80 hertz. The sampling rate value is 80 hertz means the omega here it will be 2 pi of that sampling rate, that is 80. So it will be 160 pi. So the signal get repeated after 160 pi. So if the signal get repeated after 160 pi, so the signal I can again draw this one as 4 pi at 160 pi, right? This is 160 pi, and if I add 100, this will it will become if I add 100 it will become 260 pi, right? So 260 pi it becomes pi, and at 60, so the 60 pi it will be 60 pi it will be pi. So this will causes problem. This is called as alias. Okay. So suppose if I so if this value of so in this instead of 80 hertz, right? So if instead of 80 hertz, suppose if it is for example, I take this one as 120 hertz. Okay, so the sampling rate is 120 hertz. So what will be my omega? Omega is 2 pi of the sampling rate, right? So that must be equal to 240 pi. Okay. So if this is a case, okay, then so this is my initial signal, right? So since it is 240, right? So 240 it is 4 pi, and this is this becomes uh, 140 pi, and then this is 340 pi. So here you can see there is no aliasing, right? So if it is no aliasing, the signal can be recorded. So you can see the sampling rate. Sampling rate here it is 120 hertz, which is greater than the sampling rate of my original signal 100 hertz, right? A Nyquist sampling rate 100 hertz, right? So if that this is the case, my signal can be recorded easy. Mm. So here if you see, this is omega 1, that is 10 pi, and omega 2 is 30 pi. So what is my 2 pi of fm of 2, that is 30 pi. So fm2 is 15. So here if we see fm of 1 is nothing but 5. So this is my greater value. So my Nyquist sampling rate is twice the fm2, the maximum frequency, that is 30. Right, 30 hertz. So what is my sampling rate? Sampling rate is equal to 1 divided by t. That is 1 divided by 0.04. So you will get 100 divided by 4 is 25 hertz. So here we can see the sampling rate is less than Nyquist sampling rate. So this will lead to alias, right? And the signal cannot be recorded. So the next question is x of t is equal to sine sinc 100 pi t sinc 200 pi t. So if it is plus, there is no problem. Since it is in multiplication, you have to convert this one into a Fourier transform value. So if I convert this one into sinc 100 pi t to Fourier transform, so my omega value, it will be from plus 100 pi to minus 100 pi. Okay. So similarly, for if I convert this one into a Fourier transform value, x of j omega. Okay. This is x1 of j omega. Okay. This is x1 of x1 of t, and this is x2 of t. Okay. So this is x2 of t. So if I take a Fourier transform, it will be 200 pi. This will be minus 200 pi. So if I take since it is in multiplication at Fourier transform, you have to convert this one, right? That is the x j omega is equal to x1 of j omega convolution of x2 of j omega. So if I convolve these two, I will get a signal like this. Okay, like this, and the omega will be from 300 pi minus 300 pi to 300 pi. Okay, so from this I can obtain the omega value. The maximum value of omega value is 300 pi. So the omega I can write it as 2 pi of fm, right? That is nothing but 300 pi. So my fm is nothing but 150. So what is my Nyquist sampling rate? Nyquist sampling rate is 2 times fm, that is nothing but 300 hertz. And next one is Nyquist sampling interval. On divided by fs, that is equal to 1 divided by 300, which is measured in terms of seconds. Okay. So that's all about the video. So if you want any other problem is, you comment in the description box. If you want to see the other videos, you refer to the playlist which is given in the description box. Thank you very much for your patient listening.